Hi, welcome to my island on this fine Tuesday afternoon. As you can see, I am a little underdressed for having visitors, but I do want to use this opportunity to take a look at how we can see all of the different clothing items we have. Hold on, before we do that, I want to catch this butterfly. There we go. Oh, wait, there's another one. Yeah, there's a friend on my island today that, too much time. There's a friend on my island today that's paying premium for butterflies, and so I want to make sure I can get that. Anyhow, why don't you follow me to my abode, and I will show you how we can figure out all the different ways that we can create an outfit using the clothes that I have in my wardrobe. Please excuse the mess. I have to go visit Blathers. Okay, so let's take a look at the wardrobe. Now, as you can see, I have a pretty fair amount of clothes in the wardrobe. Clearly not all of what I want, but let's see what we've got. In the neighborhood of shirts, or tops rather, I have 30 options available to me. What we're going to do is we're going to pair up a top, a bottom, and a sock and a shoe. So that's 4 separate items that we're going to put together: shoes, socks, bottoms, and tops. And what I want to know is what are all the different, or how many different possibilities of outfits can I put on from this closet with the number of tops, bottoms, socks, and shoes that I have? That's my question. In the past, we've done a question like this using a probability tree or a decision tree or even an area model to show how to compound or how to put together these different options. But as you can see, I have a lot of shirts here, and I am not going to be the guy to try to draw a tree model to figuring out the number of options. So basically, if we count these up, we see that I have 30 shirt options. From the bottom, it looks like we have 6 on this side and 4 on the other, so there's 10 options for bottoms, 10 bottom options. I have sock options, so I have 5 sock options over here, and I have 3 sock options over there. So that'll be 8 sock options. And for shoes, I have 9 on the left side and 6 on the right side for what looks like a total of 15 shoe options. So let's go over that one more time. 30 tops, 10 bottoms, 8 socks, and 15 shoes. So with those options, my question to you is, how many different outfits can I put together? What we're talking about is the counting principle or the counting rule. And the counting principle tells us the number of possible outcomes for a given probabilistic situation. For instance, when you see a statistic that says that your chances of getting bitten and killed by a shark are 1 in 3.75 million, we know that a probability is a possible outcome, a selected outcome, being bitten and killed by a shark in this case. Out of all of the possible outcomes, that 3.75 million is a number that comes from somewhere, and odds are that 3.75 million is calculated using the counting principle. In our case, we're going to calculate the number of possible outfits. The number of, let's do this here, the number of possible outfits, given that we have 30 tops, we have 10 bottoms, we have 8 socks, and we have, I think it was 15 shoes. And a moment ago I said that you could do a decision tree if you wanted to give that a shot. So basically it would look like this. We would say, here are all the, well, let's just start with one shirt. Here's a red shirt, right? Remember, I have 30 tops. And this is just one of 30. So starting with 30 tops, I would have 10 possible shorts. And so that would be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those are each nodes for the bottoms. And then for each one bottom node, we said we have 8 possible sock combinations. So we would have to do another combinations of socks. 1, 2, 3, 4, 5, 6, 7. And you can see I'm doing this very messily because honestly, this is not the way we're going to get this done. We have one shirt going to one bottom, going to 8 different socks, and then I have to add 15 shoes, and each one of these nodes has to have another 15 branches coming off of it. So clearly, a visual model is not going to be as easy to work with as when we've done, say, a rat through a maze with 3 different options, or use an area model to figure out who has blue eyes and brown hair, those kinds of things. So in our case, we need to come up with something a little more mathematical to do it. And fortunately, you already have. You know that when we did, say, an area model, let's just focus on red shirts and blue shirts. So here are shirts, and here are shorts, say. If we were just focusing on that, and I had 5 red shirts, 5 red, and 6 blue shirts, and I had to go with that 4 pairs of black shorts and 3 pairs of blue shorts. Then to find the number that goes right in here, you already know, based on how we've discussed probability, you already know what to do with the 6 blue and the 4 black. We would multiply those. So that's what we're going to do with all of our possible outcomes for our outfits in the game. If I have 30 possible tops times 10 possible bottoms times 8 possible socks times 15 possible shoes, and that equals all of the potential outfits, that would give me, let's see, 300 times 120, makes sense. So that'll be 36,000 possible outfits from 30 tops, 10 bottoms, 8 pairs of socks, and 15 pairs of shoes.
You did it. You figured out that having a total of 30 top options, 10 bottom options, 8 sock options, and 15 shoe options gives you 36,000 different outfits that you can put on any given day. Now, of course, I wouldn't necessarily put on every one of those options because sometimes you could just make yourself look a little bit silly, as I have just done. So, have fun with that. Hope you learned something. This is the fundamental counting principle, also known as the counting rule. This is how you find the total number of outcomes possible in a given set of choices.